grade 12 physical science students. Welcome to another support video from the Opinionated Science Educator. This video is made in response to a question that was on the physical sciences group about why esters with a higher molecular mass are less fragrant. This question was posted on the physical science study group, and it asks, why are esters with a higher molecular weight not have a strong smell? And this video is here to answer that question. Okay, now what I have here are the reactants that form an ester. The first is a carboxylic acid, and I know it's a carboxylic acid based on the COOH group, double bond oxygen OH, and the other is an alcohol. So this is methanol and ethanoic acid. Okay, an ester forms when this part of the carboxylic acid reacts with this part of the alcohol. So obviously, based on what you learned in grade 11, there must be a collision that will change bonds. So this is where, because remember, water is formed, so the OH comes from the carboxylic acid and the other H comes from the alcohol. Okay, so now the reaction has taken place. Here is the water that was formed with the OH coming from the carboxylic acid, the other H coming from the alcohol. Okay, so when we name this, remember the alcohol group takes on the prefix, so this would be methyl ethanoate. The ethanoate coming from the carboxylic acid that was involved in the reaction. So what exactly are esters? Well, they are organic compounds that are formed when an acid, it actually can be any acid, and an alcohol combine and release water. Esters formed with carbolic acids are the most common, and that's what we deal with in the grade 12 physical science curriculum. Esters formed from simple hydrocarbon groups, such as the carboxylic acids, are colorless, volatile liquids with a pleasant aroma, and they create the fragrances and flavors of many fruits and flowers. Esters with low molecular weight, such as ethyl acetate, are usually volatile fragrant liquids. Fats, which are the other type of esters, are solid esters. Now, esters are widespread in nature. So let's look at some of the physical properties of esters. Just a reminder, esters are derived from carboxylic acids. In terms of their boiling points, small esters have boiling points which are similar to those of the aldehydes and ketones. Esters, like the aldehydes, are polar molecules and so have dipole-dipole interactions. And there are also van der Waals dispersion forces along the chains. However, they do not form ester-to-ester hydrogen bonds. And that's why their boiling points are lower than, for example, the alcohols or the carboxylic acids. Now, small esters are very soluble in water, and this decreases with an increasing chain length, as shown in the table below. So methyl methanoate, very soluble. In fact, we say it's miscible, whereas ethyl propanoate has a solubility 1.7 grams per 100 grams of water. Now, one of the reasons for this is the partially positive hydrogen atoms in the water molecule can be sufficiently attracted to the lone pair of oxygen atoms in the ester. Okay, so coming back, there is the ester, the lone pair of electrons on the oxygen atoms, which are there. That is what makes the molecule polar, can attract the slightly positive hydrogen atom from a water molecule, and therefore esters do form hydrogen bonds with water molecules. In fact, there's a possibility of two possible sites where these hydrogen bonds can form. So that explains why the esters are soluble in water, especially the smaller esters, because like dissolves like. Water is polar, it will dissolve the polar ester molecules. Now, here is a bigger ester molecule. So again, the polarity of the molecule is caused by the lone pairs of oxygens that are found in the middle with that double bond O functional group. But along the chains on either end, now there will be more van der Waals forces because those ends are non-polar. So the long chains are non-polar. There will be van der Waals forces along the chains, but the dipole-dipole moment forces within the center of the molecule. And it is because of that reason, as the molecule gets larger, because the intermolecular forces are now getting stronger because there are more with the longer chain, the solubility as well as the boiling point will, the solubility decreases and the boiling point will increase the larger the esters are. Now, I've shown you that the boiling point increases as the chains get longer, but what is vapor pressure? So let's look at what vapor pressure is, and we'll look at the relationship between the intermolecular forces in a liquid and vapor pressure. So firstly, vapor pressure happens in a container that is sealed. Some of the liquid molecules at the surface evaporate into the vapor phase or become a gas, and this is actually a dynamic equilibrium system. So there's a point where it reaches that equilibrium. So because they cannot escape the container, the vapor molecules at the surface exert a pressure on the wall of the container. The vapor pressure is a measure of that pressure exerted by the gases above the liquid in the sealed container. A liquid with weaker intermolecular forces evaporates more easily and has a higher vapor pressure. So the smaller esters have a higher vapor pressure and will evaporate more readily because there are less intermolecular forces. Now, the larger ester molecules, which will have more intermolecular forces because of the increase in the length of chain and molecular weight, will therefore have a lower vapor pressure. So as the length of the chains increases in the esters, their vapor pressure decreases, less will vaporize, and so you will smell less. There will be less to smell. Okay, so now we know that the smaller esters will vaporize more than the esters with the longer chain. So how does that then link to our smelling them? So an odor is a volatile chemical that we will smell, and the type of molecule that produces an aroma we call an odorant. Now, these compounds are generally small with small molecular weights, and they readily dispersed into the air due to their higher vapor pressure. So because the esters with the smaller chains have a higher vapor pressure and easily become vapors, then they will mix with the moisture in the air, and that will dissolve in our nasal cavity, and that's how we sense smell.